Howdy folks, in this video we're going to walk through some of the items in the Intro Computer Science curriculum for TEALS and also take a holistic look about what are the principles behind this curriculum, why is it the way it is, how should you approach it. So let's begin at the beginning. Where did this course come from? In the most literal sense, our Intro CS course is based off of a UC Berkeley course, number CS10 by Dan Garcia and his team, called The Beauty and Joy of Computing. It's a course that's been very successful at Berkeley in the past few years at attracting a very wide, very broad audience of people, most of whom would never ever take a computer science course were it not for this course. But where did that course come from? Well, for the past couple decades, computer science educators have noticed that we have a problem, which is namely that a lot of people aren't studying computer science. And when we look at the reasons, they are many and varied, but an emerging theory is that we're teaching it wrong. When you think about what computer science is, computer science consists of really two different parts. Learning language skills around computer programming, but also learning problem-solving skills that are applicable even more broadly outside of programming. And often when we start teaching computer science, we start with an intro programming course that exposes students to all of these things at the same time. Students are trying to learn a new syntax, a new vocabulary, and at the same time a new set of problem-solving skills. So an emerging theory of computer science education is to try to focus at first less on the linguistic components of programming and more on the problem solving, or what has become known as computational thinking. And Dan Garcia's Beauty and Joy of Computing course is one great example of a course that focuses more on the computational thinking aspects of computer science to hook students into the more important, more interesting, more immersive elements of computer science. It so happens that Dan's course and a number of other similar courses around the country have gotten together and are working to create a new advanced placement course called Computer Science Principles. That's why the TEALS course is called Intro to Computer Science Principles, because it shares a lot of DNA of that new AP Computer Science Principles course. What do I mean when I say DNA? Well, if you go over to the College Board website and start reading through the materials on this new AP course, you'll discover that the Computer Science Principles course, the new AP course, is built around 7 big ideas in computing and 6 computational thinking practices. Yeah, I won't read these out loud for you. You have eyes and you can take a look at them. But as we look at these are some of the areas that we are thinking about as we talk about computational thinking. What does it mean to study computer science from a conceptual point of view and not less from a rigorous literal point of view? And this is really the DNA of our TEALS course. Now, our TEALS course is an intro to computer science principles. We don't do all of the things on this list. We've scaled it back to provide a lower level course that's even more broadly available. But we certainly have a focus on creativity, abstraction, data and information, algorithms, and programming, less so on the internet and global impact. We absolutely want to connect computing to other areas, other subjects, which we do through our culture days. We certainly create computational artifacts in Snap. We're certainly doing a lot of abstracting, analyzing problems, communicating, and even a little bit of collaborating. So that's the bones of this course and why this course is taught the way it is. That's why we use the Snap programming language instead of a text-based language, because we want to take away the linguistic part of learning computer science and focus just on the problem solving and computational thinking so that students can get a footing before we start throwing this rigorous new language at them. So if you look at the structure of our Intro CS course, it's divided into 6 units, well, 7 or 8 actually if you count the small unit 0 that comes at the beginning, and if you think also about the CS Culture Days. But these are the main content units. Unit 6 is the culmination of the whole course, and it's really important that Unit 6 happens. Unit 6 is about software engineering. It's an opportunity for students to build their own project from the ground up, design, brainstorm, spec, plan, and implement. Now, the pieces of the rest of the course are arranged to provide students a useful set of computer science skills that will help them build that project. Units 1, 2, and 3 are pretty essential and fundamental to programming and to computer science, and there's really no way to build a useful Unit 6 project without all three of those units. Those three units also have to go in order, 1, 2, 3. Units 4 and 5 are more leaf nodes. If you have time, you'll do units 4 and 5, both of them. If you run out of time, you may cut part or all of unit 5 or even part or all of unit 4. It's not essential to have those units to be able to do a programming project. So when we look at the structure of each unit, we'll notice that the units are kind of backwards engineered around a final project. So the units are therefore project-based. The idea is to expose students to each of the core concepts they need to be able to complete the project. The projects are meant to be open-ended to an extent and to be creative and fun. So if you look at a unit, the way it's going to look is something like this. The labs that contribute core concepts that the students are going to need, and then a final project that takes a lot of the content from those labs and some of what you're teaching to support those labs and kind of culminates by putting all those pieces together. So now let's take a look at the actual Intro CS curriculum materials. As always, you will get to those materials starting from the TEALS dashboard, tealsk12.org/dashboard. And down at the bottom, we'll see the link out to the Intro CS curriculum. The Intro curriculum has been built on a platform called a Git book. So this is a Git repository in which we've stored a series of essentially web pages in the markdown format that can constitute the pages of the Git book. But the Git book also provides some other useful features I'll talk about in a little while. This first page currently is a placeholder and very, very soon will be replaced with a document that explains some of the information I'm talking about right now and some other tips and tricks just around the curriculum materials themselves. This second page, the curriculum map, is probably the most important page in the curriculum because it'll give you the all-up view. It's going to separate the curriculum into units, and in this view, each row of one of these tables represents one day of your class. Now, because TEALS schools are all very different from each other, I have to give a caveat here. When we say one day, we're expecting schools to be a 45 to 50-minute period, and that's what we're expecting for one day. If your school has a different length of time, you may need to rebalance some of the time as we've distributed it. And of course, every class is going to move at a different pace, and even within the pace that your class generally moves, some days you'll just be off that pace, some days you'll be on. So take these segments with a grain of salt, but in general, this represents each row represents a day of your class. So we can see we have this unit 0, which consists of about 4 days, really just basic getting to know you, stuff that you want to do at the beginning of the class, first day of school, culminating with a very basic exploration in Snap. Here we have our unit 1. If you look towards the end of the unit, we'll see that it ends with a project called the Animated Nursery Rhyme. And then we have this other item here called a Culture Day. So one of the important parts of the Intro Computer Science course is connecting computing to other fields, other disciplines, and to what's going on in the world. So in each unit, we've suggested 1 or 2 culture days where you'll take a day and stop programming, stop working on your projects, and instead discuss some relevant, interesting topic that connects computing to something else. And we'll talk more about that later. You'll also notice that we've provided you multiple days of class to work on the project, and we'll also talk more about that in a minute as well. So let's look at Unit 1. So Unit 1 consists of 1, 2, 3, 4, essentially 5 lessons, where the last lesson is really just wrapping the project for the unit. The final project in this unit is an animated nursery rhyme. Now, if you've gone through the training materials, you've already built most of the projects for the class. You haven't built this one largely because it should be really easy for you. So we wanted to give you the more challenging projects. Basically, the students are creating a scripted play, a nursery rhyme in Snap, and the focus of this project is going to be on just, can we animate sprites? Can we put directions in a useful order? Can we get a handle on Snap's event-based model of calling the sprite behaviors? So, to build up to that project, we have these other 4 lessons, each one including its own lab. The first one is just kind of a walkthrough of Snap and includes the kaleidoscope lab that you guys have done. In the second lab, students are expanding the set of blocks that they are familiar with and getting comfortable with doing their own research and figuring out what a block does. In the third lab, we're starting to draw some basic shapes. So we're needing to put instructions in a sequential order to complete a task. In the fourth project, we're going to start learning about actually animating sprites and using costumes, which is going to be absolutely essential when we put all of those things together into the project. And so all of the units are built in this general fashion where we have final project and the labs that build up to them. That's even true in Unit 6, where the project of Unit 6 is the final project, which is a medium large scale project of the student's own choosing. But in this unit, the steps that we're going through to build up to the project are the steps of engineering. So some basic design and brainstorming, choosing a project, defining the requirements, creating a plan, and then spending the rest of the time implementing the project. There are a few extra resources down here at the bottom of the Git book. One is just some links to additional resources. As we mentioned, this curriculum is built on a Git repository, and so this page will explain to you how you can contribute back to the curriculum by either forking and making changes and then pushing those changes or submitting a pull request of those changes back to the mainline curriculum, and we can incorporate some of what you do in your class. Now, I mentioned earlier that in most units there are when we work on projects, there are days that are just said project day or lab day. And what we mean on those days is the focus of that day is going to be to continue a large-scale lab or project that was started on a previous day. But we don't mean that those days should be entirely devoid of instruction. Those days should be structured like any other day with a warm-up, 10 or 15 minutes of instruction followed by practice time. And what you'll be doing in that instructional block is reviewing issues that you saw as you observed the lab the previous day, maybe showcasing some student work that is exemplary or has misconceptions embedded in it. And so you want to structure these. So we have a lesson plan here that's sort of a general template for what you might do on one of these lab days. And then similarly, we have a general template for what you might do on your culture days. We'll also be adding a page that has a whole bunch of suggestions of topics and materials you can use for culture days. So what will be interesting things to bring into the class to talk about on those days. So that's a general overview of the materials that are available for the main curriculum in Intro Computer Science. One other really useful note is if you click on the title of our Git book here at the top of the table of contents, the Git book will take you to a meta page, and one of the most useful things about the meta page is that you can actually download the entire curriculum as a PDF file or an ebook, e-reader format that you can then take offline with you. One other detail I'll mention is as you go to do labs, we have each lab included as a web page in the Git book, but we're also including links to a Word document and a PDF file version of that lab that has been designed to be a little bit more friendly for printing out and handing to students. So for example, in this first lab, this handout version of the lab leaves space for students to write in some of their guesses, or for example, further down to fill in responses in a table, and etc. So if you try to do that directly with the material in the Git book, you'll find that the spacing doesn't quite work out when you try to print it out. So just some useful materials that you can check out there. In future videos, we may go into more depth on individual tips and tricks for the various projects and labs, but for now, we recommend just start working your way through the curriculum, try out some of the labs. You should have already tried out most of the projects. And here's a set of additional resources that will help support you in teaching this class. So we already know about the TEALS Curriculum Git book that you can get through from our dashboard. And the additional materials library, which is right below it on the dashboard, has a wealth of other materials that teams have built over the years teaching this class for their classrooms. So if there's ever a case where you want something else, a different version of a project, some extra labs, some slides, check out that library and see if you can find what you're looking for. You may find it really helpful to read through the SNAP manual. There is a reference manual for SNAP. It's written for a pretty high-level reader, but so it's probably not appropriate for your students, but might be useful for you. You can also head on over to the GitHub repo for SNAP itself if you're curious about how things work under the covers. As I mentioned, our course is originally based on the UC Berkeley CS10 course, and every semester Berkeley puts up an online course page with videos, slides, lab assignments, walkthroughs, tutorials, so those may be useful as well. If you click on this link here, it'll take you to the most recent semester of that course, but you can also navigate to find previous semesters. This is brand new, really exciting material down at the bottom here. The BJC team, Dan Garcia and folks, are working on creating a high school version of their course to be used more broadly, using some of what they learned working with us at TEALS and some new research they've been doing. They're actually rolling out this curriculum in the 2015-16 school year for the first time. So, it's forked off of our curriculum quite a few years ago. So it's a slightly different take, some different focuses. Keep in mind that the BJC High School class is meant to be a year-long class, and it's meant to be an AP CS Principles class. So it should be both more rigorous and longer than the TEALS intro class. But you'll find a lot of useful resources there as well. And you'll notice as you look at the Berkeley materials and at the BJC High School materials, some things are directly in common between the two, other things not so much. Other great resources to keep in mind are the Piazza discussion forums. CSUnplugged.org has some great activities you can do to help teach concepts without actually needing computers. And if you're curious, you can head on over to the College Board website and learn more about the upcoming CS Principles class and read through the curriculum framework that I mentioned earlier on in the video to read more about those computational thinking practices, the 7 big ideas in computing, and how they all fit together for this new AP standard that will be coming in 2016-2017.